Exercise 3C, question 5. It's coming from here, page 69 in your textbook. Y equals e to the power of ax divided by b times x. Stationary point there. We've got to find a and b. So these are the questions that often get a little bit tricky with the algebra. Now, we're going to find the first derivative, and stationary point means the first derivative will equal 0 when x is a third. But before you start, you have a point you can work with here. So if y, what I mean is, this equation here has to give this point. Let's put those numbers in. E on 2, right, that's the y value. So I'm changing my y to e divided 2, has to equal e to the power of a times a third. Now a times a third is, I'm just going to write it like this, a on 3. It's an a. It's hard to write with this pen. Times b times a third. B times a third looks like that. To tidy it up, you can do this, and you'll get equals e 3 e to the a on 3 divided by b. We could also times both sides by 2. I'll just go to the next line then. E equals 6 on b, e to the a on 3. So all I did there was times by 2 that side, times by 2 that side. Can get an expression for b. Therefore b equals pulling the a out of the power, I think, would be a bit harder. But I am getting a nice expression for b that I can maybe use later. So b equals 6 e to the power of a on 3 divided by e. All right, so I have times both sides by b to get my b equals, but I've also had to divide both sides by e. Right, so that's a little thing I can use later on. Right, you would need the working, by the way. So I've erased it just to make room for myself. This function here, should I quotient rule or product rule? I think I might product rule. Y equals e to the ax times bx to the minus 1. So this is another video where I'm using product rule, but you don't have to. You can use quotient rule. Don't let me turn you off quotient rule. Okay, the derivative. So I've got a function, something times something, u times v. So I'm making my list. U, the function is e to the power of ax. The derivative of that, a e to the ax. The v function, I'll be careful here, it's 1 on bx. Right, now the derivative, I would be chain ruling here. I'd be going minus 1 times bx, inside stays the same, that becomes, subtract 1 there, and then you've got a times by b. That's the inside. So that all comes out to be a minus b on b squared x squared, or bx all squared. Let me write it like that, b squared x squared. Okay, so that whole thing's on the bottom of a fraction, bx all squared, and I just actually did the squaring. I guess you could cancel here, couldn't you? That might be a nice little move. Equals minus 1 on b x squared. Yeah. All right, so the derivative coming from oov times oov, no, not times, oov plus OOV because I'm using product rule. So where's my first OOV? Those two put together. So we'd have a e to the ax on bx, right? So it's that one, and then I'm doing this one and this one. We've got a plus normally. However, when we come to times that by that, we'll have a minus in there. So let's write that in straight away. Minus e to the ax on bx squared. All right. Do I want a common denominator? I don't, maybe, but let's try, see what happens without a common denominator first. So the derivative, when the x was a third, equaled 0. So then it follows that if I make my x's thirds, the answer to this equation here will be 0. So I'll be having a e to the a on 3, all right, so that x is a third. You've got to be careful not to miss any. That x is a third, so I've got b times a third. It's the same as, if we're dividing by a third, it's the same as timesing by 3. You can do this yourself to check. Now here, we'll have a third square. Let's do that bit first. We've got e to the a on 3 again. It's on b, but here we've got a third times a third. So that'll be 1/9 times 1/9. Now, if I tidy that up, I will get 9. They'll cancel. Remember, you can change, you can multiply fractions by anything you like. You just got to do it top and bottom, right? And we've talked about that in class. And that has to equal 0. How can I make that equal 0? Well, they've got the same denominator now, and b is just a number. So I can forget it. I can just think, well, how would you make the top equal to 0? So, like, therefore, you know, given that this is all just one denominator, let me rewrite it again. I'm a bit limited for space, so I wouldn't, normally this would be an extra line in my workbook, but imagine this is all one big fraction, and I've got a common denominator now of b, right? If I want to make that 0, well, I just need the numerator to be 0, so I'd have 3 a to the e all to the power of a on 3 minus 9e. I'm seeing common factors in this. We've got 3 as a common factor. Oh, I forgot they equal 0. We could actually divide by 3. I won't, I'll just leave it. But the e is common to both, right? So maybe different color. This is in the first term, and it's also in the second term. Let's pull it out. So we've got e to the power of a on 3 brackets. We're left with a minus 3, and it's got to equal 0. Now this bit here can never equal 0. No, it can. If a is 3, it can. No, it can't. What am I saying? You can never, apologies, I'm a bit tired. You can never raise something to a power and get 0, can you? So you can block that out from your mind for a minute. If I had an a out here, I could make the a 0, but it's not. Is it? There's no, you know. How do you solve that? Right? You can't. There's no number you can put there that spits out 0, right? If that power is 0, you get the answer of 1, right? So in my mind, I'm ignoring all of that. I'm just going to look at this bit. Therefore, a minus 3 has to equal 0, because if this is all 0, the whole thing's 0, 0 times whatever that is, therefore a equals 3. Tick, we found a. We already had an expression for b, so So therefore, b has to equal 6 e to the 3 on 3. That's just a 1. 3 divided 3, 1. So you've got 6 e on e, cancel is 6. B is 6. So A equals 3, B equals 6. Okay, and I'm just going to go back to the question because the question was a bit bigger than all that. I think I wanted to know the stationary point. What might I want to keep here? Where's my derivative? Maybe keep that for now. All right, we'll just get rid of some of this working out and make some room. All right, so looking back at the question, find A and B, but then it says state the nature of the stationary point. Think about that. Well, I know what A's and B, I know what my A and B are now, don't I? No, I know what the stationary point is. So how are you going to state the nature? I mean, you could just sketch the graph. You could say, well, the function y, here's the function now, it's e to the 3x on 6x. You could go to your calculator, graph it, look for x is a third and see is it a max or a min or a point of inflection. So you can do it by graphing or you can do it with sign diagram. We now know that the derivative is 3e to the 3x on 6x minus e to the 3x on 6x squared. I know that on the sign diagram of the derivative, dy dx, that there is a stationary point where the x is a third because that was told to me. So maybe I want to look to the left and test the number 0. So what would the derivative be, in this region lower than 1/3 where x is 0? Okay, and it would be undefined. It's an asymptote. Okay, so I would need another value, maybe a 1/6. Right, that was no good. I think if it was me, I would just graph it, use my calculator and look for this point. But we can do it this way as well. If we put in a 1/6, because we just need to know if we're positive or negative, right? Shouldn't be too hard. It would mean the derivative would be 3 e to the half, which is square root e. Let's write that. This is all just positive still. On 6 times a 6th, which is 1. So that's a positive number, minus, it's not much of a positive number, I guess, minus, what are we testing here? Another square root e on 1/6. So it comes out like that. So if I make x is a 6th, I'd have that squared. I have a 1 on 36. I have 6 on 36. It's 1/6. If I divide by 1/6, same thing as times in by 6. So I get minus 3 root e. It's negative, right? Okay, testing out here. Hopefully it's a little bit easier. Let's test at x equals 1. All right, so we'd have 3 e to the 3 on 6. That's a half. All right, and it's a positive number, and it's minus a cubed on, what am I testing? 1 on 6, which is positive because you've got, it's not, yes it is. You've got like a half of this minus a sixth of this. I've got a half of something, we just call it x, minus a sixth of that something. I'm positive, right? So we have a minimum at that point because the gradient goes positive. What I've done there is just say let e to the cube, e cubed equal x, just so I can see it easier. It's like a half minus a sixth, right? Okay, I think that's enough for that question. Thank you.